Okay, so we'll be starting with the components of a computer. Okay, what we need for our programs to run. Okay, in computers, everything that has to do with computers is split between two camps or two categories. First, we have the hardware and the software. What do we mean by hardware? Hardware refers to anything that is that we can touch, made of materials. Okay, anything that is made from materials, we call it hardware. Okay, the other category is called software. Software refers to operating systems, programs, anything that is outside the realm of hardware. Okay, now in order for us to use computers, the software must interact with the hardware. Okay, we cannot use software unless it is on a hardware. Okay, same thing, a hardware cannot function without software. Okay, so let's take an example. For example, what you see on your screen here is the Firefox browser. It's an internet browser. Okay, we can open new windows, we can open websites and everything. Okay, this is a software. Okay, this is called a software. This is an example of a software, a simple example. Okay, so another example is Windows itself, this operating system. An operating system is a special kind of software. It is installed directly above the hardware. It allows us to use the computer. As you can see here, I can use my mouse to select folders, browse what's inside these folders. I can do all sorts of stuff. Okay, the operating system is the software that enables me to do so. Okay, so most software, most, note that I said most, not all of them. Most software needs an operating system to run on. Okay, there is, for example, let me give you an example. Are any of you familiar with Mac OS, or let's say Android and iOS? You're
Yes.
familiar? Yes. Okay. So notice there is a version of Firefox for Android. There is also another version for iOS, and this one is for Windows. Okay, so it's essentially the same software with the same services, with the same functionalities, but for different operating systems. Okay, so it runs on the operating system. Another operating system is Android, for example, with which you should be more familiar with, because I believe, I presume that most of you have smartphones. For example, applications are software. Okay, but for example, the camera on your phone is considered hardware. Okay, now let's say, for example, let's give you an example of a computer hardware. Okay, let's give you an example of computer hardware. Okay, For example, what you see before you is called a motherboard. Okay, the motherboard is the centerpiece of any computer. It groups the other parts, it connects them with each other. Okay, for example, here slots the CPU, the processor. Okay, the processor, which is the brain of your computer. Okay, let's give you an example of what a processor looks like. This, for example, is a processor. Okay, the processor goes inside this socket. Inside this socket, it is designed to house the processor. Okay, now just a moment. Okay, so this right here is a processor. Okay, it's a processor. It goes in this socket right here. Another important component, for example, let's see, RAM. This is a bare bones RAM. Okay, now what this is, you may hear it be called memory or RAM, whichever. It's the same thing. RAM is short for random access memory. Okay, let's go to another type of memory. For example, a moment. For example, what you see now is a hard drive. Okay, it is used for storage. Now, both the hard drive and the RAM are types of memory, but they serve two different, very different, distinct purposes. Okay, so the hard drive, for example, is responsible for storing data, storing media, data, whatever it is. Okay, for example, you can install programs into a hard drive. Okay, into a hard drive. You install programs onto a hard drive, but where do these programs run once you open them? Can anybody tell me where these programs, once you open the program, where does the program run? Okay,
It
so
runs in the RAM.
exactly, and we're gonna see an example of how it runs in the RAM. Okay, okay. So, for example, let's take a look at a program that is installed in our hard drive. Okay, let's go, for example, with any program. We have to access our hard drive. We go to this PC and then the local disk. Okay, see, program files. Here, notice we have Adobe, Android. We have different folders. Okay, each one contains either one or several programs. Okay, for example, For example, here we have, just a moment. Okay, so where were we? Here we have Wireshark. Okay, it's a folder named Wireshark. I have a program in this computer named Wireshark. Okay, here's its installation. Okay, installation files. It is installed inside the hard drive. Okay, inside the hard drive in a folder named program files, and then another folder named Wireshark inside the program files folder. Okay, so the data, the entire data of this program is located in the hard drive. Okay, so it is kind of permanent. For example, let's say I shut down my PC. I shut down my PC, and when, for example, tomorrow I turn it on, I would still find the program installed. Okay, because this type of memory doesn't lose its data whenever there is no electricity or whenever the current is cut. Okay. But, however, for example, let's say I run Wireshark now. Let's say I run Wireshark. Let's try to run Wireshark. For example, this is a program, just a program. Okay. Let's see where it is running. Notice here, Wireshark, it is consuming RAM. Okay. It isn't consuming anything else. Okay. The disk. Notice here we have disk usage, which represents the use of the hard drive itself. Okay, notice it is using 0 megabytes per second of the hard drive. Okay, but it is using, now it's 88.7 megabytes of memory, which is short for the RAM. Okay, it is using RAM. So any program, once you open the program, once you try to run the program itself runs on the RAM. It's a rule of computing. Okay, programs run on the RAM, random access memory. Here we have 16 gigabytes of RAM. Okay, notice we have much more on our disks. Okay, here we have, I think I have 180 or 180, yeah, 179 gigabytes. Okay, I have another hard drive that has 117 gigabyte, 117 free, but it has 1 terabyte, 931 gigabytes. Okay, for example, me personally, I use this hard drive to store media. Okay, the other hard drive, this one, C, local disk C, I use it to install the programs. Okay, so now, for example, whenever I close Wireshark, whenever I close it, it disappears because it no longer consumes memory, the RAM. It is deleted from the RAM. Deleted from the RAM meaning if it's closed. But notice here, the program is still here. I can reopen it whenever I want. Okay, I've just reopened it. It came back. It is consuming 83 megabytes of RAM. Okay, but when I close it, it is deleted from the memory. It is closed. Okay, but its data is still there. Okay, it is not deleted. If I want to delete a program, for example, if I want to delete a program, I go to the control panel, and then a program here. we have a prompt to uninstall a program. Okay, just a moment, just accept some late arrivals. Okay, if anybody has a question, feel free to ask. Okay. So let's continue. The programs, as we have said, run on the RAM. They run on the RAM, but they are installed on a hard drive. Okay, let's take an example. For example, let's run a program like Microsoft Word. Okay,
Sir, can you tell us about the difference between the role of the RAM and the CPU?
the role of the RAM and what? Please repeat your question. Let us first finish with this example, and then we're gonna go back. Once I'm finished with this example, you will understand the role of the RAM and the hard drives uh, more easily. Okay, so I opened a program. Now this program is open. It is executed in the RAM. Okay, notice here we have 71 or 65.8 megabytes. Okay, it's consuming RAM. It is open in the RAM. Now, any changes that I write to this document, for example, let's write a title. Okay, let's write a title, for example. Okay, title, and then, for example, we're gonna underline this title. We're gonna make it bold. Do some changes. Okay. Now, this document was blank. Now, I've worked on this document and made some changes to it. Okay, I've made some changes, made some progress on my document. For example, let's say I'm writing a document. Now I figured out the title. Now, let's say I want to exit this program. I have stuff to do. Okay, notice here it prompts me to save my work. Okay, want to save your changes to this document? If you click don't save, a recent copy of this file will be temporarily available. Okay, but it will be deleted later. Now if I want to find this exact file with the changes that I've made to it, I have to save my work before exiting out of the program. Okay, for example, let's click on don't save. Okay, whenever now if I reopen Microsoft Word, my file is nowhere to be seen. Okay, nowhere to be seen because I haven't saved my progress or my work before exiting out of the program. Okay, now let's say, for example, let's redo the changes. For example, let's go with this one. Let us write some gibberish just to make sure that we've left an imprint of this on this document. Is equal to, for example, the length of the cube to the power of 3. Okay, let's save this document. Let's go save this document. We can use this one to save, or file and then save as. Where do we want to save this document? For example, let's save it to the desktop, okay, so we can find it easily. Let's call this document volume. Let's call it volume and save. Now I've saved this document, okay, I've saved this document. Now these changes currently are in the RAM, but when I save this document, this document is saved to the hard drive itself. Now if I exit this program, it will close everything and delete everything from the RAM, okay, but I will find a copy with the exact same changes that I've made here in my hard drive. Specifically, we've saved it to the desktop, so we should be able to find it in the desktop, okay? Now, whenever if for example, I turn off my computer and I turn it on again, I will find the file still in the desktop, sorry, okay? Because I've saved this file. Let's go and exit out of this program. Notice here we have a new file called volume. It is the exact same file that we were working on earlier. Okay. Now let's reopen the file and examine the content. Okay. Notice here we have the exact same changes, or the exact same work that we did just a moment ago, okay, because we've saved this file. Okay, let's say for example this is now running in the RAM. Don't forget, whenever you open a program, it is running in the RAM. Now for example, let's go and make some more changes. Okay, of a ball is equal to okay, 4 divided by 3 times p times r to the power of 3. Okay, this is the volume of a sphere or a ball. Okay, now for example, let's go and try to exit of this document. Okay, let's not save now. Everything is deleted from the RAM, but notice now whenever I open the file that we were working on just now, the new changes are nowhere to be found because I haven't saved the work after I'm finished modifying the file or adding to it. Okay, if you don't save your work, then it is automatically deleted. You will not find it anywhere. Okay, but for example, let's is equal to 4 out of 3 times to the power of 3. Okay, so now I've made the changes again, and let me save. This is a shortcut to save, or we can go to the tiring way. Let's save the document. Now, if I exit of this document, it is deleted from the RAM, but the changes are still brought to the hard drive, to the file, to this exact file. Okay. Now, when I open volume again, notice the new changes are here. Okay. Do you guys have any questions?
Sir, I didn't understand the last point. Can you please repeat?
Yes. Okay. So notice what we've done just now. Just a moment. Looks like we have new arrivals. Okay. So what I was saying earlier is, notice that when we created the document, when we opened the program the first time, the program was running in the RAM. We made changes to the file, but without saving the changes. Okay. When we didn't save the changes, when we reopened the file was empty because we didn't save our work. There is no copy of the file that we were working on the hard drive. That is why when we exited out of the program without saving, the program didn't create a file on the hard drive that contains the changes that we made. Okay? However, when we saved the file, what happens when you save a file is the program takes all the changes, all the modifications, all the work that you were doing on the exact file and creates the file in the hard drive. Now, the difference between the hard drive and the RAM is, I repeat, I'm repeating this so you can understand it. You have to understand the difference between the RAM and a regular hard drive. Okay, the RAM is only for the programs to run on. Whenever you open a program, this program is running on the RAM. Okay, it is not running on the hard drive. It is opened from the hard drive. The files of the program are on the hard drive, but the program is closed. When you click on the program to run it or to execute it, for example, it is running on the RAM now. Now, if it is running on the RAM and you made changes, for example, if you want these changes to be permanent, if you want to find these changes, to find the file as is, uh, as you were working on it, okay, you have to save your file, save the changes you made to the file. Okay, when you save something, it brings the data from the RAM and it puts them in a file on the hard drive. Okay, on the hard drive. Now, whenever, for example, you turn off your phone, or you close the program, no matter, because the changes are in the hard drive. If you want to access them, for example, in our case, if I want to access these changes or this file as is, I reopen the file. Now, all the changes that I've made are present in the file because I've saved the changes I've made before exiting out of the file. Okay, that's the difference. For example, let me simplify this for you. For example, let's take your phones. Your phones also have RAM and ROM. Okay, you're familiar with this terminology. Are you guys familiar with this terminology?
Not really.
For example, when you buy a
Sir,
new,
we are familiar.
yes, whenever you
Sir, we
buy
are only familiar with the
with the
RAM.
RAM, yes, the ROM represents
Yes, but with the
the regular memory. Okay, for example, most phones these days come with either 4, 6, or 8 gigabytes of RAM. with either 64 or 128 or 256 gigabytes of storage. Okay. Now the storage.
So basically,
Uh,
basically the RAM is only for operating the systems, all the
Yes, the
programs
system
from
and
the
the
hardware.
applications, not only the system. It is responsible for running
Oh,
the system and the applications. Okay?
yes. Can you tell me the role of the CPU?
The CPU. Yes, we're gonna tackle the CPU just in a bit. I wanna just make sure
Oh,
that everybody understands the role of the RAM and the memory, the regular memory, or the hard drive. Okay? If you guys
okay,
have
sir.
understood, we can move on to the CPU. If not, please ask away.
So the regular memory is the same as hard drive?
Yes, yes. Regular memory. Not only hard drives. I'm using the term hard drives, and then we are gonna see the types of this memory. Okay, they vary. There are many types of this memory, but the role, or the goal that this memory serves is the same. Okay, it saves the changes permanently in the hard drive. Okay, but the RAM, for example, if I were, for example, to turn off this computer right away, this call will be ended. Okay, I will not be participating in this call anymore, because whenever I turn off my computer, the RAM is cleaned, is wiped clean off. Okay, everything in the RAM is wiped off. Okay, whenever you turn off your computer, or whenever you close a program. If I were, for example, to press this X button right here, I will be kicked out of this meeting. Okay. For example, same on your phones. For example, if you opened an app, for example, let's say you opened YouTube. Okay, you're watching a video, and then some stuff came up, and you had to go, or for example, you had to go to class. For example, you just press the home button. Okay, to exit of the application. But the home button is analogous to me pressing this button right here. It minimizes the app, but it doesn't close it. Okay, the app is still running on the RAM. Now if I check, for example, my resources right here, notice that Firefox, which I've just minimized, is still running on the memory. Okay, it is taking, for example, it is running multiple processes. Now it is taking 639 megabytes of RAM. Okay, it is still running, but I minimized it. For example, if you guys, for example, let's say you're watching a video and then you press the home button. Now YouTube is not present on your screen, but it is still running on the RAM. For example, you've studied for, let's say, 3 hours, and then when you open YouTube, more than likely you will find the video you were watching still on. Isn't that right?
It's true, sir. So we basically need the RAM in order to operate the whole
Yes,
system
yes.
and
Why
save the
does why
content.
didn't the video
Okay.
disappear? Why didn't the video disappear? Quite simply because it was running in the RAM, and you haven't cleaned the RAM. Okay. However, if, for example, you close YouTube from the recent apps screen, the video is lost because you've removed YouTube from the RAM. YouTube is closed. Therefore, any changes that were made are not saved. Okay?
Okay, sir.
Okay. So now let's move on to, if everybody is on the same page. If you guys have any questions, feel free to ask. If anything is unclear, just say the word. We're all on the same page. Okay, so let's now move on to the CPU, or the central processing unit, the unit that comes right here, that goes right here in this socket. Okay, for example, this is a i5 12400. Okay, it is a processor, it is an Intel processor. This goes into this socket right here. Notice it is practically the same shape. It holds it. Okay, and the CPU, what is the CPU used for? The CPU is analogous to the brain of the computer. Okay, the brain of the computer. It is responsible for doing all the calculations needed to run the computer. Okay, without a CPU your computer won't even turn on. Okay, a computer will never turn on without a CPU, without memory, and you won't be able to do anything without a hard drive, because your system itself is stored in a hard drive. Okay, is everybody on the same page with me? For example, let's see the task manager. For example, let's go to the performance tab. This here simplifies everything for you. Okay, now notice the processor is going between 20 and 50% usage. Okay, now this usage is due to this meeting. For example, it consumes processor resources. It is responsible for example, decoding the sound waves and everything. Okay, for example, it is sharing the screen, and let's not forget, I'm recording this session using this program. This program is also running on the RAM. Okay, it is recording this session as we speak. Okay, here we have memory, which refers to the RAM. Okay, now we have 16 gigabytes. We are using everything, all in all, with the operating system and all the programs that are open. We are using 5.1 gigabytes out of 16. Okay, now this disk here, this is the main hard drive where the programs are open. Okay, for example, if I click on Chrome, notice the usage of this SSD spiked a bit, and then it went back to zero. Okay, because why is that? Why did that happen? Because this program, the files of this program are stored on this disk. Okay, disk 0, on this disk. When I open the program, I read the files from the disk and then execute them, load them to the RAM. Okay, I need to read from the disk. That's why the usage of the disk spiked right here. Okay, and it went back to zero because I finished loading the files from the disk to the RAM. Okay, notice now the RAM usage went up from 5 gigabytes to 5.6 gigabytes. Okay, that's due to this program, Google Chrome, running on the RAM now. Okay, now this hard drive's usage is zero because we're not using it for anything. Okay, we haven't opened any file from this hard drive. Okay, is everything clear? If anybody has a question, please.
Sir, I didn't understand the last part.
Okay, so let's redo the whole thing. Let's go back 20 minutes. Okay, I've told you that the programs themselves, the files of the programs, are stored inside the hard drive. Okay, let's, for example, let's search for Google Chrome. Okay, the one that I've just opened. Okay, let's go. Here we have a file, forgive me, a folder named Google. Now we have a folder named Chrome. Okay, here is Chrome. Here are the files of Google Chrome, the program that we've installed. Okay, so we found Google Chrome. Okay, the files of the application or the program are stored in the hard drive. Okay, but the program itself is closed. Okay, it is closed. Now whenever I open the program, what happens is these files, the necessary files for the running of the program, are loaded from this hard drive, which is disk 0, to the memory. Okay, for example, let's try and close Google Chrome. Let's close Google Chrome. Notice when I closed Google Chrome, the memory usage went back from 5.8 gigabytes to 5.2 gigabytes. Okay, that's because Chrome was wiped from the RAM. Okay, but it is still installed in the hard drive, in this disk. Now whenever I click on Google Chrome to open it, what happens is that the files necessary for the running of the program are loaded from this hard drive or this disk 0 right here to the memory. Okay, so the usage of this disk 0 should spike a bit, should go up, for example, to 35% for a bit, so long as so that the files can be read and loaded from the disk 0 to the memory. Let's try it. For example, let's open Google Chrome. Now notice here the usage spiked just a bit. Okay, it didn't spike like last time. For example, let's go and open another program. Let's open Microsoft Edge. Now the usage spiked more. Notice here the usage spiked to 63%. Okay, it spiked to 63% and then it went back to 20%, and then now it is 3 and 4%. Negligible. Okay, it is negligible. Now that spike was due to the files being loaded from the disk to the memory. Okay, notice now when I opened Microsoft Edge, the memory usage jumped back to 6.1 gigabytes. Okay, because the files are loaded from disk 0 to the memory. Is it clear now?
Yes, sir.
Okay, so this part right here is called the CPU, the Central Processing Unit. Okay, the Central Processing Unit is like the brain of the computer. It is responsible for running the programs themselves. It is the one that loads the files, that gives the order for the files to be loaded from the disk to the memory. Okay, and it is responsible for example, whenever you write something, it is the CPU that interprets everything. It is responsible for everything. Okay, it is responsible for the calculations, for example, managing keyboard, the mouse, everything. Okay, everything is done through the CPU. Okay, this is called the Central Processing Unit. It is like the brain of the computer. If, for example, the computer was without a processor, it wouldn't even turn on, as I've said earlier. Okay, is everything clear? Notice here we have the CPU usage is between. Now we have noticed that the Firefox is using 12.6% of the CPU. Why? Because we are doing a meeting. Okay, it is calculating and responsible for the images, for sharing my screen, for recording this session. Okay, now all of this is done through the CPU. Now, did you understand the role of each component? These three are the main components of a computer. Did you understand their role?
Sir, can you tell us just the main role of the CPU?
The main what?
The main role of the CPU.
The main role of the CPU is the running of the computer. The CPU is the most essential part of the computer. Okay?
So what is the difference between the CPU and the RAM?
For example, the RAM just holds the data. It holds the data. The RAM is like a bucket, okay? But you need something to fill the bucket, okay? The muscle of the
So
computer.
I need the thing that is going to bring the program and run it on the RAM.
Yes, it is the one that is responsible for running the program or copying the files and running everything. Now, when you, for example, we have some, for example, some programs that do calculations. Okay, let me give you an example, a final example before we go. We have this one, dev C++. It is responsible. For example, let's run some code. Okay, let's run some code. Here we have a program. Yes, it has a C++ program. It takes two numbers and it adds them together and gives us the result. The one responsible to do these calculations is the processor. Okay, let's run the program.
Okay.
For example, let's run the program. Here we have a equals to, for example, let's say 6. Let's give b 8. The result should be 14. We have la somme égale à 14. Okay, this is a simple example. This is just a simple program. For example, if you didn't have a processor, which component is responsible to give you the result of this calculation? You don't have a brain to run this process. Okay, you need a CPU. Now the CPU, this is just a simple example. The CPU can do much more complex operations. Okay, this is just a simple example. Okay, a simple example.
Okay. So
We can, for example,
it's like the mind of
let's
the computer.
yes, exactly. Now, for example, let's take, for example, Photoshop. Now, the changes that you make to a picture using Photoshop are done using the CPU. The CPU calculates everything that is needed to make the changes to your picture, and then it applies the changes. Okay? That operation requires multiple calculations that are done using the CPU. You don't see the calculations themselves because you only see the results, okay? But behind the scenes, the CPU is doing a tremendous amount of work, okay? Let's go, for example, let's go and give a final example before we leave. For example, let's say I've opened a document on Microsoft Word. Let's insert a picture, okay? We can, for example, insert a picture like so. This picture, now I can resize the picture and I can rotate the picture. I can do whatever change I want to this picture. Now, everything that I'm doing now requires specific calculations to give me the result that I'm looking for, okay? These calculations, everything that you see here is done using the processor, okay? The way I'm moving the image, like you seen earlier, is used, I can do that using the processor, okay? The processor is the one responsible to calculate how I am moving this image, where the image will be next time. If I move my mouse in this direction, the image should go in that direction. Everything is calculated using the CPU. Now, is everything clear?
Yes, sir.
Okay, so we're gonna stop here for this session. Quickly before we go, I want to just ask you a question. When are you free this week? Don't you have sessions this week?
Normally in evening of Monday.
Monday evening.
Yes.